Hey everybody! Today we are going to do a lesson on simplifying radicals. Simplifying radicals is very important in a class like geometry because one of the highlights of geometry is using the Pythagorean Theorem and working with special right triangles, and even when you do trigonometry where you're going to use sine, cosine, and tangent, a lot of right triangles, a lot of missing sides, lots of Pythagorean theorem. That means a lot of taking square roots. Pythagorean theorem, a squared plus b squared equals c squared, where a and b represent the lengths of the legs of a right triangle, and c is the hypotenuse, the length of that longest side across from the 90-degree angle in, of course, a right triangle. So not all square roots can be evaluated to be a nice number. So let's chat about that, okay? So we are going to simplify radicals today. If I have something like the square root, so the root is where something comes from, the square root of heart times heart. A square root is finding out what number was squared. Now maybe on the side, heart times heart is equal to smiley face. So this problem perhaps is presented to you as the square root of smiley face. If you could break that down into heart times heart, well, now you could see what was being squared, what was being multiplied by itself. That means that the square root is what number was being squared, because anything times itself, we know that means that you are squaring it. And the square root of, for now, no complicated stuff right now, but the square root of heart squared is going to be heart, because the square and the square root are what we call inverse operations. So, a couple other things that we can chat about. Well, one of them, let's say we had 3 by 3 as the dimensions of something back in the times of Pythagoras, which was like a really, really, really long time ago. Now, they didn't have these numbers. These are called Arabic numerals. Pythagoras was using Roman numerals to multiply. Multiplying, doing arithmetic was really hard back then, so they did their multiplying by using shapes and geometry. Geometry was super easy. Arithmetic was super hard. So 3 times 3, they made dimensions 3 by 3. So that's why when you see dimensions of a poster, a picture, wood, whatever, they use that X to mean the dimensions, right? So they would make a 3 by 3. 3 this way by 3 this way. 3 on that side, 3 on that side. So now they made a 3 by 3. How many little squares do we have altogether when we did 3 by 3? Well, we got 9 squares. This shape that it makes, a 3 by 3, is what we know as a square, and the operation of doing 3 times 3 is what we call squaring. Everything that we do in math, we need to be able to undo. So to undo squaring 3, they invented the square root of 3, all right? Why this symbol? I don't really know. Maybe they thought of it as like a little hammer. You break down this apart and you break it into 3 by 3 again, okay? So if you have the square root of something and you could break it down into something times itself, then the answer is just one of those things in a nutshell. But this is using symbols. This is crazy times, right? Keep in mind, sorry if you hear the music outside. Keep in mind, what if we do something like square root of star? And what if I told you that star is equal to smiley face times, oh my gosh, it's so loud, music note, right? So that means star is smiley face times music note. But smiley face, well, that was heart times, we still have, keep that square root over the whole thing, got to keep the roof over the right head, times music note, okay? Heart and heart is smiley face. Well, that's the only perfect square. Remember, it's heart by heart, 3 by 3. It makes a perfect square. So we can take its square root. The square root of that, only one of those hearts comes out. This music note, though, it's got to stay inside. Okay? So, it's a little bit too bright. Sorry. That's a little bit better, right? Yeah. So we might have a case like this. But let's look at this using numbers, okay? Let's say we had something like the square root of 18. So here is example 1, okay? This is also an example that it wouldn't be a bad idea to memorize. The ones I'm going to do right now, you should memorize them. They come up a lot, okay? Square root of 18. We're going to do something called a prime factorization. So we're going to factor 18 all the way down. Prime factorization. So, they have that little daycare kindergarten thing, prime time, go back to the beginnings, go back to the itty bitties, the little numbers. 18, it's even. If 18 is even, it's definitely 2 times something. Times what though? 2 times 9. Now, maybe you learned that, 9's a perfect square. We're lucky we got to 9. So we can just do 3 square root 2. But do you all understand why? So let's keep going. 2 is a prime number. 2 is the only even prime number. A prime number has 2 distinct factors, 1 and itself. That means that 1 is not prime because its only factor is 1 times 1. That's not 2 distinct factors. Distinct means different. So if that's on the SAT, you're welcome. And also 2 is the only even prime number because every other even number will be divisible by 2. So it won't work. 9 is certainly not prime. So I'm going to keep going. And 9 is 3 times 3. We don't deal with the ones, okay? We stop now here because 3 and 3 are both prime. They're the smallest odd prime numbers. Only even prime number. So the prime factorization for 18 is 2 times 3 times 3. You really want to break it down, okay? So this name, proper name for this is called prime factorization. Sorry, it's a little squished. That's the prime factorization. Now, that means that that's really, I'm going to use an arrow, not an equal sign, because it's not an equation. So let's kind of do an arrow. That's what's really under the radical, okay? We call the expression underneath a radical a radicand. So this guy, 18 in this case, is the radicand. And then that symbol, make sure you put the little check on it, otherwise it's a division, right? That's your radical. And then in here, if you have a little number, another vocab word, that is the index. Now, if there's no index, it's an invisible 2 for square root. 2 for square. Squared is second power. So if there's no number here, that was supposed to be a little number symbol, but it was so tiny, I don't know if you could see it. Okay? If there's nothing written, it's an invisible 2. I know we're used to invisible 1s and 0s. Now we got an invisible 2. So if 2 times 3 times 3 is my prime factorization, think of that as the heart times heart. It makes the square. It's a 3 by 3, right? So that's the 2. We got something squared, 3 times 3. So one of them comes out. They come out as just 1, all right? So 3, so just from here, scooching around. 3 comes outside, and the square root 2 stays inside. So remember that. A lot of times people bring the wrong thing out and leave the wrong thing in. So you want to really watch out for that. Excuse me. Now, you'll learn later in the future, if there's a 3, it's a cube root or a 4th root or a 5th root, Well, you're just going to look for groups of that many. So because this has an invisible 2, we're looking for groups of 2. Okay, let's do a couple more examples. Then I'll help you start the worksheet, and then you're going to do the rest on your own. So let's look at another one. So say example 2. And let's say that we're looking at, try to give you a number that's not on the worksheet. Let's do square root of 50. Now, a lot of us know, and the directions will say simplify. I should have written that on top. I apologize. So for that one too, simplify. A lot of people know the phrase troll or trolling, right? Like this person's trolling this person on the internet. Don't be such a troll. Well, the troll concept comes from the story The Three Billy Goats Scruff. I think that was the name of it. And that was a story about a troll, an ugly little troll that lived under a bridge. Okay, evil, ugly troll. I don't know what trolls look like. Okay. That's the troll. And he's a miserable, miserable guy. And then the cute little billy goats, right? They want to come across the bridge, whatever a billy goat looks like, okay? The 3 billy goats gruff, they want to come across the bridge. But what happens? This stupid troll, well, that wasn't nice to call him stupid, but he wants to eat them or something. I don't know, eat them, chase them, be mean to them. You're going to have to look it up. But he wants to be mean to them, right? So basically what the troll does is he taunts them and argues with them. At the end of the story, the billy goats outsmart the troll and they all get across the bridge. So why am I talking about this troll? I kind of use the troll to kind of think of how to do these examples and make them a little easier to remember, okay? So let's say the billy goats are trying to go across the bridge. And really as a pack, the billy goats, they make 50. Okay, how many billy goats are there? Maybe there's 3, 4, 5 billy goats, okay? The troll, he's the one that lives under this little gutter of the bridge. So it's the invisible 2 for a square root. We need the prime factorization for 50. You don't always have to make a tree like we did up there. You sometimes could just do it right underneath the radical. So 50 is even. I'm going to use 2 times what? 25. Well, what's 25? 5 times 5. So these are my billy goats. As a pack, they're 50. But when I break them apart, 2, 5, and 5. But the troll, he's trolling. He says you could only leave from under the bridge in groups of 2. You have to use the buddy system or you can't leave because I'm an annoying troll. So the annoying troll is only going to let them out from under the bridge in groups of 2. They have to be with a buddy. So 2 and 5 can't go together though. Here's the group of 2. So basically they help each other out. One climbs on the other's shoulders or something. I don't know. But they go out. Okay. And so in the next step, it's going to come out as a single 5. Okay. A package deal. 5 comes out and 2 is inside. What if the 5 comes out front, but there was already something out there? What do you do then? So let's build on this. For example, 3. I'm just going to add on to example 2. So with my marker, example 3. What if I have, well, for example 3, what if I had a 3 in front? The 3 already escaped. He already got out from the troll. You know, he already outsmarted him. So when the 5 comes out, the 3 and the 5 are next to each other. What operation is between them? Multiplication. So what will your final answer be? For example number 3, it'll be 15 square root 2. And that's the only difference there. Okay? So I'm going to grab the worksheet. That's really what you got to do. If you want to use my billy goat thing, knock yourself out. I'll do a couple on here to get us going, and then you're going to finish the rest on your own. I think you're going to do great. Okay? So let's do, maybe we could just do the first 4 together. So let me lower this brightness. Or maybe I'll do like one in the beginning, middle, and end, you know. The first example is -4 square root of 70. Okay, so what's next? -4 square root of, now it's even. I'm going to be a little dramatic, make my square root kind of long, my radical symbol really long, so that I could try to break down 70. So if you need to go on the side and make a little factor tree, go right ahead. But I am just going to try for right now to just do it right here and fit it on right this step. 70, it's even. 2 times what? 2 times 35. Okay? 35. And again, if you needed a tray, you could do this, okay? 35 is what? Well, you should know your times tables. 5 times 7. But prime, prime, prime. 2 times 5 times 7. It's just the plain radical. That means there's an invisible 2. That's the troll, and that's his rule. You can only go outside and play and get out of this bridge if you are in groups of 2. Not if you are a 2, but if you're in groups of 2. I don't have 2 2s. I don't have 2 5s. I don't have 2 7s. You can't break 2 into 1 and 1. We break it down by multiplication. That's what prime factorization is. So what does that mean? That means it cannot be simplified. So we're going to write cannot is one word, be simplified. And that means cannot be simplified. I'm just going to rewrite -4 square root 70. That's as far as it goes to be simplified. So that was number 1. Okay, let's jump ahead and let's do number 6 together. So if you want to press pause right now, sorry, it's bright again. If you want to press pause right now and do numbers 2, 3, 4, and 5, and let me know in the comments how long that takes you so I can kind of gauge your speed. That'd be great. And then just come back in when you're ready to do number 6, okay? So if you're watching now, I'm assuming it means you're ready to do number 6. Number 6, we have -3 square root of 27. I'm just going to rewrite that because it's a little small and I can't get too zoomed in right now. And the directions up there in bold are to simplify. So we're going to do what we just went over. What multiplies to give you 27? Maybe you're able to jump right to the prime factorization because you know some stuff about 27 by heart. If not, 3 times 9 might be your first step. And then 9 is 3 times 3. So this one's a little dicey because we got a lot of 3's happening, but follow the rules. Next step, -3. This one's already out. The troll couldn't catch this one. He's already outside. So -3 out front, inside of the bridge where the troll lives. Make sure we don't lose that negative, okay? We have now a 3 times 3 times 3. So again, it's like you put on your x-ray vision glasses and you're like, 27, what really makes 27? Or if you bought it at the grocery store and you looked at the nutrition facts for 27, on the back label, it's going to say 3 times 3 times 3. That's what makes 27. The prime factorization, the ingredients, okay? We're here. It's a regular square root. There's nothing inside. It's the invisible 2. So that troll's rule is you're only allowed to go out if you can make a group of 2. Otherwise, you have to stay inside. So they go out as 1 3. Not as 1, but as a single 3. Now, drawing an arrow so I know where this leads. Okay. The -3 was there. The 3 came out. And another 3 stays in. Next step. What's -3 times 3? -9. And then root 3. So that is the final answer, and it cannot be simplified any more than that. So just to color coordinate a little bit to clarify in case you're a little confused, because there's so many 3's, I don't want you to get confused by all of the 3's on the paper, okay? So we have that -3 that was sitting out front the whole time, okay? Now this 3 times 3, maybe it came from those 2, maybe it came from the other 2. It doesn't matter which 2. 2 3's is 2 3's. And when it comes outside, right there, it becomes this 1 3 right over there. And then the other 3 just stayed behind right there. And what happens when we mix pink and blue? Well, I guess it should make purple. I don't know how well that's going to show up, but that is -9 square root of 3. Okay? Too bright, maybe. So that was number 6. And why don't you get going on some of these other examples. And then I will do number 15 with you. So keep going, work on your own. Or 15? Actually, I'll do number 9. So go ahead and do 7 and 8, press pause. And when you're ready for number 9, you can join me, okay? All right, if you're watching right now, that means you are ready for number 9. And on number 9, we have -4 square root of 64. So I'm just going to try a little bit zoomed in like this. That should help. Oops, and right there. Sorry, it's a little too small, I think, no? Okay, that should help. So here, number 9, I'm gonna slide this up a bit. -4 square root of 64. 64 is one of those numbers that has a big, long prime factorization. So there's kind of 2 ways that you could think of this example. So I'm gonna do it with the troll and the billy goats, and then I'm gonna do it another way. So let's say you were on a roll doing the trolls version. 64, well, that's 2 times what? I always start with 2 with evens. 32, that's even again. 2 times what? 16, still even. 2 times what? 8, still even. 2 times what? 4, still even. 2 times what? 2. So what is my prime factorization? The prime factorization is, sorry, I have an alarm going off and bumped my head. I dropped my phone, so. Okay, the sacrifices I make for you guys. Another 2, 2, and 2. 1, 2, 3, 4, 5, 6. There's 6, hitting the wall. There's 6 of them. So next step, -4, just hanging out front. That's already there. And that's 64. If I really use some x-ray vision, because I have amazing eyesight, 2 times 2 times 2, that's 3 of them. 4, 5, 6 of them. Now it's just a regular square root. Again, square 2. The troll's rule is 2. You can only leave from under the bridge in groups of 2. Boom, boom, and boom. Well, now what? Because no one's left under the bridge. So what do? Well, -4 times 2 times another 2. Remember, it's multiplying, not adding. Times another 2. Square root of what? Really, you don't have to write anything. There's really a square root of 1 inside, and the square root of 1 is 1. Since you know that 1 is the multiplicative identity, you don't need to really write anything for this, so you can get rid of that. Just remember, it's not 0. And I wouldn't use the word cancel, because cancel means it becomes 0. So like -5 plus 5 cancels. So this just becomes 1. It simplifies to 1, so we don't have to worry about it. And then, so that's this next step here, over here, next line. -4 times 2, if you wanted to break down your work, well, that's -8. That's the first 2. Times 2 times 2 is 4. But you might think it's easier, to be honest, to keep doing times 2. -8 times 2 is -16 times 2. And -16 times 2 is -32. And that's the final answer. All done. What's another way you could have done this problem? Well, you could memorize your square roots. The square root of 64 is 8. -4 times 8 is -32. Okay? So that would be the end of this one. So you can go ahead and try the next few. And I'll probably do one at the end with you guys. Maybe I'll do number 23 or 24. So press pause. And I will see you in a minute when you get to the end of your worksheet, okay? All right, if you're back, if you're watching, that means you are ready for help at the end of the worksheet. So let's see what you might need some help with. Sorry, I was just trying to color code that guy right there. How's that? Okay. I don't know. You're already past that, right? Which one might you need help with? Maybe we should check in on 18. How does that sound? 4 square root of 42. If you already got 18, well, maybe you don't need help, but maybe we should check it and make sure you're doing it correctly, right? 18. We have 42, and again, that's an even number. Let's use our 2. 2 times what? Half of 40, half of 2, 21. That's not even. Can't use 2. What multiplies to give you 21? We should all know 3 times 7. So I have a 2, a 3, and a 7. Those are the billy goats we got. We got 4 outside. 2 times 3 times 7. But guess what? Cannot be simplified. So if that's what you got for this, but you weren't sure if that was right, you were right. So I hope you got that all on your own. That would be amazing. And we're just going to rewrite 4 root 42 is as far as we can go. And that's the end of number 18. All right. And let's finish up this worksheet with number 23. Maybe it scared you because the numbers were big, and I really think you could get 24 on your own. So best of luck. 245, not even, but it does end in a 5. So if this ends in a 5, it's divisible by 5. If you don't remember how to divide by 5, well, let's do some long division. 2, 4, 5. In my head, I would just think 250 divided by 5 is 25 divided by 5 with an extra 0. 25 divided by 5 is 5, so 50. But that's 245, so it's 1 5 short. So instead of 50, it's going to be 49. If mental math is not for you, then let's do this. How many times does 5 go into 2? 0, I can't do that. How many times does 5 go into 24 without, going over, right? So 4 times. Don't worry, that little 0 is nothing, okay? 4, literally, that's what 0 is. 4 times 5 is 20. We're going to subtract 20 from 24, and you get 4, and then you bring down the 5. How many times does 5 go into 45? 9. 9 times 5, 45. Subtract again, and we get 0. Your remainder is 0. So that 0 is just sort of nothing, just marking that spot. 49 is the answer. Okay, so what does that mean? Does that mean that's equal to 49? No. We're breaking down 245, and we got 5 times 49. If 245 divided by 5 is 49, then 5 times 49 is 245. Okay, 5 times 49. I hope you know what multiplies to give you 49. 49, we should also know by heart, is 7 times 7. When I was a kid, I used to always think does everyone kind of think of 7, lucky number 7? So I thought, 7, very lucky. And if you have 7 times 7, you're really lucky. So I would either think the 49ers, they need a lot of luck if they want to be a good team, They need a lot of good luck. Or I would think really where the 49ers get their name, back in 1849, there was the gold rush. So if you found gold, you were really lucky. So 7 times 7, 49. That was my dumb thing I told myself in second grade or whenever you learn your times tables. So what's the prime factorization for 245? 5 times 7 times 7, right? It's a regular square root. You can only go out in groups of 2. Otherwise, you're trapped under the bridge with the troll. 7 comes out. That 7's already there. A new 7 joins it. And 5 stays inside. Final answer, 49 square root 5. Fully simplified. So you always want to make sure it cannot be simplified any further. So we're just simplifying radicals. You will do a ton of radical simplifying in geometry and algebra 2, pre-calculus, and forward. So I hope that this was helpful. I hope you can get this whole worksheet done. And if you think that you can handle this and you're going to get a good grade, then give the video a thumbs up. And if you think that you are still terrible at simplifying radicals and you just have no idea why I'm talking about billy goats and you hate my analogy or my story, then give the video a thumbs down. Go ahead. I won't be hurt. I don't care. Do it. I dare you. So hopefully you got these done. Okay? Have a great day.